7, 6, 5.
The first U.S.-built lunar lander in more than 50 years.
But this is an important mission anomaly popping up, and the company Astrobotic says it is doing it.
The successful inaugural launch of the Vulcan rocket marks a significant milestone in the realm of space exploration, as it not only demonstrates the technological prowess of United Launch Alliance, ULA, but also symbolizes a new era in spaceflight. Launched from Cape Canaveral, Florida on January the 7th, 2024, the Vulcan rocket not only demonstrated its capabilities, but also helped send American spacecraft to the moon for the first time in more than 50 years. Since its founding in 2006, United Launch Alliance, a joint venture between aerospace behemoths Boeing and Lockheed Martin, has emerged as a major force in the sector. Notwithstanding the high cost of its rockets, United Launch Alliance has established a reputation for dependability in the launching of diverse payloads, especially top-secret military missions intended for the U.S. government. ULA's initiative, the Vulcan Rocket Project, is a calculated step toward modernizing and improving the Alliance's launch capabilities. The goal of the Vulcan rocket, which is intended to replace the outdated Atlas V and Delta IV rockets, is to increase ULA's competitive advantage in the quickly changing space launch industry. On January the 7th, 2024, the Vulcan rocket had its maiden launch from Cape Canaveral, Florida. It was a painstakingly planned and accomplished operation. The launch site made the perfect backdrop for this historic occasion because of its well-known historical significance in space exploration. The launch, which was scheduled for 2:18 a.m. Eastern, took place in front of both amateurs and professionals in the aerospace industry. The countdown that went smoothly was followed by the precise start of the Vulcan rocket's journey. The previous day, the rocket was powered up at 3:58 p.m., starting a series of operations that ended just after midnight with propellant loading. A perfect liftoff was made possible by the rocket's 1 million pounds of propellants. The Vulcan rocket's engines ignited seconds before liftoff as the countdown continued uninterruptedly, sending the vehicle hurtling into the gloomy Florida morning sky. The first stages of the rocket's flight proceeded without a hitch, demonstrating how well the rocket's engineering and design worked. The rocket's two smaller side boosters were successfully removed around 2 minutes into the flight, and the rocket, which was powered by liquid oxygen and methane, burned in the vast empty space with an unsettling blue color. Shortly after separating from the Vulcan rocket, Astrobotic reported a propulsion system issue that hindered the spacecraft's ability to orient itself toward the sun for power. While mission engineers were able to regain control, the faulty propulsion system is causing a significant loss of propellant, leading Astrobotic to consider alternative mission profiles. The uncertain status of the lander's ability to soft land on the moon has cast doubt on the success of the mission. The Peregrine lunar lander's failure to enter its correct orientation in space resulted in a critical drop in battery levels, jeopardizing the planned soft landing on the moon. Astrobotic, which agreed to a 50% discount for flying on the new Vulcan rocket, faces not only the technical challenges of resolving the propulsion system issues, but also potential financial implications. Live video broadcasts caught crucial moments during the booster separation and liftoff, providing spectators with an up-close and personal glimpse at the momentous occasion. Notable moments included the ignition sequence at T-10, the liftoff, and the booster separation that followed. Real-time commentary on the booster's flawless performance was given by a launch official, who emphasized the accuracy and potency of the Vulcan rocket's propulsion system. The Peregrine lunar lander, developed by Astrobotic Technologies, is the main component of the Vulcan rocket's lunar mission. Pittsburgh-based Astrobotic, a space robotics company, deployed Peregrine on this historic mission with success. The Peregrine lunar lander is a robotic spacecraft that is intended to do a soft landing on the lunar surface. It is an essential part of the progress being made in lunar exploration. Sinus viscositatis, also referred to as the Bay of Stickiness on the near side of the moon, is where Peregrine is supposed to land as part of this mission. The mission's scientific and exploratory goals are highlighted by the selection of this mysterious site, which aims to increase our knowledge of the lunar geology and characteristics. With a fascinating name that translates to the Bay of Stickiness in Latin, Sinus viscositatis offers a distinct area to explore. This area was chosen for scientific reasons, and it is anticipated that Peregrine's landing will provide important information about lunar conditions. The mission is in line with larger initiatives to investigate various lunar landscapes, improving our understanding of the geological makeup and history of the moon. NASA is actively involved in the moon mission of the Vulcan rocket through the Commercial Lunar Payload Services, CLPS program. As part of their partnership, NASA has awarded $108 million in financing to Astrobotic Technology, a significant collaborator in CLPS. This funding demonstrates NASA's dedication to utilizing business collaborations for lunar exploration, as it is allocated for the transportation of 5 experiments to the lunar surface. The CLPS initiative is a key component of NASA's larger plan to work with private partners to lower the cost of lunar missions. By contracting out payload delivery services, NASA can concentrate on science goals and encourage private space industry innovation. For the past 16 years, Astrobotic has been unwavering in its dedication to making the moon accessible to the world. However, a recent setback involving the Peregrine lunar lander has prompted a meticulous evaluation of the mission's trajectory and raised questions about its responsible conclusion. Just 6 days ago, the Peregrine lunar lander encountered a propulsion system anomaly, leading to a careful assessment of how best to conclude its mission. This incident sparked concerns not only for the preservation of Earth's orbit, but also for the cislunar space environment. As the Astrobotic team worked diligently to stabilize the spacecraft, their primary focus became finding a solution that minimizes the risk of creating debris in cislunar space. Working in collaboration with NASA and drawing inputs from the space community and the U.S. government, Astrobotic navigated the complex landscape of determining the safest and most reliable course of action. While the recommendation was to let the spacecraft burn up during re-entry into Earth's atmosphere, the final decision rested in the hands of the commercial missions team. The decision-making process involved a delicate balance between the desire to extend Peregrine's life, operate payloads, and learn more about the spacecraft and the potential risks associated with a damaged spacecraft in cislunar space. Ultimately, Astrobotic made the difficult but responsible decision to maintain the current trajectory for Peregrine's re-entry into Earth's atmosphere. Despite the propulsion system issue, the Astrobotic mission team demonstrated unwavering dedication. The team worked tirelessly to stabilize the vehicle, activate all payloads, and collect essential payload data. Peregrine, now in space for 6 days and 16 hours, continues to leak propellant at a slow rate. Test firing one of the main engines indicated potential propulsive capability, though the anomalous fuel to oxidizer ratio posed challenges for long controlled burns. Astrobotic showcased excellence in design and construction as the hardware, avionics, software, and system architectures performed as expected in space. All payloads designed to power on and communicate achieved their objectives, even in the face of adversity. The team's ability to overcome challenges highlighted the robustness of Astrobotic's mission control and the effectiveness of their spacecraft components. Acknowledging the spacecraft's anomalous state and the potential risks associated with prolonged operation, Astrobotic opted for a responsible and safe conclusion to Peregrine's mission. While believing the spacecraft could operate for several more weeks and potentially raise its orbit, the team considered the limitations posed by the propulsion system and prioritized a controlled end to the mission. As Peregrine is approximately 234,000 miles away from Earth, the collaboration with NASA continues to update and evaluate the controlled re-entry path. Assurances have been given that Peregrine's re-entry poses no safety risks, and the spacecraft is expected to burn up in Earth's atmosphere. Rigorous analysis in collaboration with the U.S. government validate this assurance. Despite the challenges faced with the Peregrine lunar lander, Astrobotic CEO John Thornton expressed pride in the team's accomplishments and their ability to overcome enormous challenges. The mission has provided valuable insights, and the CEO looks forward to sharing more remarkable stories after the mission concludes on January 18th, expressing confidence in future lunar missions achieving soft landings. In the face of adversity, Astrobotic's Peregrine lunar lander mission exemplifies resilience, responsible decision-making, and collaborative efforts within the space exploration community. The challenges encountered, though unexpected, have contributed to the collective knowledge that will undoubtedly inform
and enhance future lunar exploration endeavors. That is all for this video. We will be back soon with another informative video. Don't forget to like and share this video. Until next time.